Today we're going to talk about gravity, but we're going to add something to it, motion. First, let's talk about what we know about gravity. We know that gravity exists everywhere in the universe, and that it is a force that attracts all objects together. Essentially, if it has mass, it has gravity. Isaac Newton told us these things. He figured it out a long time ago. Galileo added on that gravity is a force that pulls things to Earth equally, regardless of the mass. So mass is not a force. Mass is just the amount of stuff in an object. Gravity acts the same on a feather as on a bowling ball. The only thing that gets in the way, and the reason that they may not fall together at the same rate, is because of other forces, like air resistance. Strength of gravity depends really on two factors. The first is the masses of the object. The second would be the distance between the objects. So we can put these into statements of relationship. The greater the masses, the greater the gravity between the objects. The greater the distance, the less the gravity between the objects. So taking an example, if the moon happened to be more massive than it actually is, the gravity between Earth and the moon would increase. Also, if the moon happened to be at a further distance to the Earth, there would be less gravity between those two objects. So we kind of mentioned earlier that mass is not the force. And so mass doesn't depend on gravity at all. But weight does. So it's kind of an interesting distinction we should be making. Mass is not weight. Mass is the amount of matter in an object, and weight is the force of gravity on an object. So your mass is going to be the same on Earth as it is on the moon, as it is on Mars. But your weight will be different because gravity on Earth is different than gravity on the moon and Mars. The moon and Mars are both less massive than Earth, so you would weigh less on the moon and Mars. This is one of the reasons why, if you watch videos, astronauts can bounce around a lot more on the moon, because they actually weigh less. So the greater the mass, the greater the force or weight. So again, mass does not equal weight. Weight depends on the force of gravity, and mass does not. So again, we know that any two objects that have mass will exert gravitational pull on each other. So why doesn't the moon just fall into the Earth? Think about it. If the moon is attracted to Earth by gravity, why doesn't it just fall to Earth? Like the same way if you let go of an apple, it would fall to Earth. Well, to answer this question, we need to add an idea that we've talked about before. We talked about this last year. It is Newton's first law of motion, which says that an object at rest will stay at rest unless acted upon by an unbalanced force. We call this inertia. So inertia is what explains why, if you're skateboarding, for example, like this picture, even if the skateboard stops, your body is going to want to stay in motion. So why do Earth and the moon remain in their orbits? Why don't they just fall to the ground? Well, I think an easier way to explain this would be to draw it. So if you think about, here, this is Earth. Beautiful artwork, sorry. All right, if you think about yourself here on Earth, there you are. And think about throwing an object. So say you could stand up really, really tall, like super tall, maybe on top of a mountain, and you threw a ball. What would happen to it? Well, say you threw that ball kind of not so hard. It would go forward a little bit, but then it would fall to earth, right? Gravity would pull it down. But what if you started throwing it a little bit harder? It would go further out, it would still fall back down to earth, right? But say you threw it just hard enough this way that it went out this far, but as it started falling back to earth, it just missed earth. And it kept missing earth. And it kept missing earth. And the inertia kept moving it forward while gravity kept pulling it down. So essentially that ball kept missing earth over and over and over again because earth is round. That, people, is called an orbit. An orbit is created by two forces. We have inertia pushing the object to the side, and we have gravity pulling it towards the other object. But these two forces act to balance each other out so that that moon or whatever it is doesn't just fall into the earth. So an orbit is created by gravity plus inertia. So inertia and gravity combine to keep Earth in orbit around the sun and the moon in orbit around Earth. It is a combination of these two things that make it so that we don't get just annihilated by the moon falling straight into us. So, in summary, why doesn't the moon just fall into the Earth? Or why doesn't the Earth just fall into the sun? Because we are in orbit around the sun and the moon is in orbit around us. An orbit is created by two forces, gravity plus inertia, working together.